Hello everyone. We are back with SciPy tutorials, and in this tutorial we'll be learning about SciPy functions. Now first of all, let us learn about some of the special functions that SciPy holds. Now SciPy's special functions are transcendental functions. The docstring of SciPy here is very well documented and you can always have a look of it. It's there on the net. Thereafter, so there are a lot of scipy special functions as you saw in that docstring, but we won't be discussing all of that. We'll be discussing some of the frequently used ones, and I'll just convert my cell as a markdown, and thereafter we'll be seeing. So first of all, we have scipy.special, right? I'll just copy this because we'll be using this a lot of times. .jn function. So this is a Bessel function that is used, and it is used for nth integer order of Bessel function. Thereafter, we have scipy.special.ellipj, right? And this is used, this is ellipj, and this is used for Jacobian elliptic function. Thereafter, we have gamma and gamma-ln function. So gamma-ln function is for more precision numbers after the decimals, right? So yeah, gamma-ln, right? And after that, lastly, the frequently used function is ERF, and this is used to find the area under the Gaussian curve. So this was about the special functions of SciPy. Right? Now let us move forward and learn about linear algebra operations with SciPy. So for that we'll have to, so from SciPy import linear ALG, and we'll be even import numpy as np, because we'll have to define the array. So let us define an array as arr is equal to numpy dot array, and let our first row be 1, 2, and our second row be 3, 4, right? And after that, what if we want to find the determinant of the array? So we'll just do print linear ALG dot determinant of ARR, right? And if we just do it, we'll get as -2. So how we are getting this as -2? Let me just take you through the documentation. This is actually taking the documentation of print. Let's go to the documentation. Yeah, so we'll go to this determinant documentation. Here we have, yeah. So for a given matrix like this, determinant is calculated in this way. So in our case, it will be 1 into 4 minus 2 into 3, which will be equal to 4 minus 6, and which will be equal to -2, and that is how we are getting the answer. Now, how about if I don't give it as a square matrix, right? So let us just find np dot 1, and let's give it as a non-square matrix, and this gives us a value error. That is what which is written over there here, that it we have to give the determinant of a square matrix, and if it is not a square matrix, we'll get a value error. Now this is what linear ALG was. Now what if we want to find the inverse of a matrix? So it's the same process. We'll write linear ALG dot inv is the function to find the inverse of the matrix, and we'll just write ARR, and this is how we get the inverse. Now what if we give a non square matrix? So in the same way, let's write np dot 1 and a non-square matrix. So this is the value error that it is giving us. Let us see the documentation for the same. So the parameters that it takes is array A and it returns the inverse of the array. It raises two exceptions or errors. First is linear algebraic error if A is not singular, because then inversion cannot be done. And after that we have value error. If it is not a square matrix, then it won't be performing. So this is about how we can perform the linear algebraic functions using scipy. Another that can be used is using SVD. Now SVD is in a singular value decomposition which can be used, and it's a simple thing. Similarly, we just have to use direct functions. So SVD of ARR, and this is the output that it is giving us. Now, some of these words can be new to you. You can always go out and find about them. And meanwhile, I'll give you the documentation for the same of SVD. Now, this is for the SVD. It factorizes the matrix A into two unitary matrices U and V, and A is a 1D array S of the singular values such that A is equal to U into S into V of, this is actually transpose, where S is the suitably shaped matrix of zeros with main diagonal S. So it's a long procedure of SVD that this function directly performs in just one line using Python. So these are the parameters that it takes, and it returns as this is our U array, this is our S array, and this is our VH array. So if we multiply all three of these arrays, we'll get back ARR, right? And it raises linear algebraic error. So if SVD computation does not converge, and these are the examples that they have noted for the same, right? Now, another thing that scipy can be used is for using interpolation. Now, first of all, let us understand what interpolate means. So, interpolate is useful for fitting a function from experimental data and thus evaluating points, but where no measure exists. So, using the function itself or using the values that we have in our data, we find the trends. And that can be simply done by scipy.interpolate. Right, so this is something that you can go ahead and explore, wherein you can take input, and after that you can, for example, you can take a sine function, and thereafter you can build a linear interpolation function on that. So that is all for today's tutorial. Furthermore, we'll be seeing some more applications of scipy.